Hello again, Kevin Culp here from Supermicro. Today's simulation is scaling a network infrastructure for your virtual machine traffic. In the previous video, we focused on provisioning a very simple network between two switches. Now we're going to jump into a more involved compute infrastructure, which seems to be more realistic for the enterprise. In this video, we will show you how easy it is to utilize SEC's network provisioning wizard to associate VLANs to many ports on a switch. In our lab example, several technologies are introduced here to show you how SEC would support your enterprise infrastructure requirements. So what would I consider before I start? Perhaps pre-planning of my network. Perhaps I need to consider the kind of back-end storage I'm going to utilize. How is the storage going to be presented to my hypervisor? What kind of hypervisor would I select? Do I consider Proxmox, VMware, KVM, Verge.io, or Hyper-V? How do I support my network connectivity of VM guest? Perhaps I need to configure microsegmentation of VLANs on my top-of-rack switch to allow interconnectivity of my compute VMs. In building my sandbox, I used a case I decided to support. My storage selection is an NFS storage server to host my VM data stores. Although there may be debate on what kind of storage technology you choose for your enterprise, I decided to utilize NFS in our lab simply because it is inexpensive and easy to implement. Besides, it demonstrates the storage networking of our Supermicro switches. I also decided to move forward with building a KVM hypervisor utilizing CentOS. Maybe there are other alternatives, but I'm familiar with Linux. This demo will show you firsthand how you can build your network infrastructure in minutes to hand off to your server colleagues the next phase of your enterprise deployment. Maybe you're a small enterprise IT shop and you share a combined role with both the network administrator and server architect. SE's here to help streamline your network provisioning deployment, providing an all-in-one unified solution. Let's review the architectural diagram for more relevance. So in this diagram, we're presenting a KVM hypervisor. We have virtual machines that will be connected to different VLAN bridge ports and trunks. We're actually passing an 802.1q trunk port for our compute traffic. So our VMs will intercommunicate with each other using this northbound upstream switch, which is our top-of-rack switch. On the right-hand side here, we have two NIC interfaces that are represented as an LACP port bonding to house or move our data store traffic to the switch and then down to our NFS storage server. We have an LACP, which is a PVID VLAN we'll configure on both particular ports. One that's associated with the NIC interfaces using LAC port bonding of our KVM hypervisor, and the other one will create also on the NFS storage side a PVID with a port bond of LACP. You can consider in both of the storage traffic a high-speed connection such as 100 gig or 400 gig or potentially even 800 gig if it exists. So you can take the traffic and basically bond it together to get the desired results of performance. On our compute side, we'll go with a 10 gig interface. In our simulation, we'll simply use 1 gig interfaces for both and port bond each of the interfaces on the storage server for both data store traffic on the hypervisor that actually is connecting to the NFS storage to present data store traffic to basically our VMs. So let's dig into the actual configuration. We'll see it in a few minutes.